In the digital world, like the real one, it helps to have extra storage space. An external hard drive stores data separate from a computer to expand storage capacity. It also preserves memory, so if the computer drive crashes, all is not lost. 50 years ago, external hard drives were the size of refrigerators. Today, they squeeze a lot more memory into drives the size of chocolate bars. On the hard drive assembly line, there's not a speck of dust. An air filtering system sucks particles out of the air to keep them from contaminating the drive and compromising its function. Production starts with the motor base. An employee installs a voice coil magnet. It's one of two that will move the drive heads to write information on rotating disks. They're called voice coils because they operate on the same principle as loudspeakers. Next, a robot places one of the hard drive disks in the motor base. A camera snaps a photo to send information to guide the robot so it positions the disk exactly. Another robot places a round metal spacer at the center of the disk, again relying on the camera's eye for guidance. It sets a second disk on top of the spacer. This is a 2-disc hard drive, but a drive can have several, depending on the amount of storage needed. A robot locks the disks into place with a stainless steel clamp. This next part is a plastic ramp. The ramp is a place to park the disk drive heads when they're not engaged in reading and writing data. Those tiny heads have been pre-assembled to one end of the head arm. They attach the other end of the arm to the lower voice coil in the base and then situate the second voice coil above it. To maintain its squeaky clean interior, a robot inserts a thin cotton filter. This filter will capture dust particles in the event that some infiltrate the hard drive. A robot now places a metal cover on the other side of the drive. Another robot then screws the cover to the motor base. With the inner workings now encased, the hard drive can be moved out of the air-filtered section of the factory. A worker collects the hard drive assemblies and slots them into a tote box. Once a circuit board has been added, they transfer the hard drives to a test chamber. Behind the closed door of the chamber, a robot swings into action. It plucks a hard drive from the tote box and plugs it into a test cell to confirm that it's functional. Outside, employees go about their daily business as the robot methodically tests each hard drive in the tote boxes. Once a tote of drives is confirmed to be operational, the chamber ejects them, and a worker then does a visual inspection of each one. She looks for scratches or other damage that could hinder its function. There's another slightly different system for testing. In this one, the employee places each drive on a conveyor that delivers it to a robot tester. Having two tester systems ensures that if one goes down, they still have another one to carry on. After all, like humans, robots are not infallible. At the packing station now, there's one last visual inspection. The employee scans the drive's serial number, so its production can be traced in the event of a problem later. She then seals it in plastic. This hard drive is now ready to accept data and ensure that someone doesn't totally lose it if their computer drive crashes.